Hello everybody, this is 13.4. So graphing from factored form application. So now we're going to apply what we've learned from graphing from factored form. Right, so what we're going to do is we're going to do the same process. We're going to find the x-intercepts first. Right, so we have our form here. We're going to find the x-intercepts, set each of them to 0. We got 8 and -4. So 8 and -4 would be our x-intercept. So here we have a little xy table chart here, graph, but there's no numbers on it. So we're going to just estimate it because we have some large numbers that we can fit. Right? So we want to use 8 and -4. So we know that the x-intercept is at 8 here, and -4, let's say it's right there. Right? So 8, -4. And then once we find the x-intercepts, we know that the vertex is stuck in the middle, right in the middle of this. So right through the middle should be our axis of symmetry. And we find that by adding both x-intercepts and cutting it in half, divided by 2. Right, so 8 plus -4 divided by 2 is 2. So that's our x-coordinate vertex. Then we substitute that into our original function for x, and we get 36. Right, so our vertex is at 236. So we know this is at 2, and the height is going to be, let's see, right there, 36, right? So 2 comma 36. So we have a height of 36 right there, right? So from there, we can draw a graph, and we also can add the y-intercept to this. Y-intercept is always this, substitute 0 into your function, and this one we got 32. So at the height of 32, see right there, so 32 is our y-intercept. And how does it apply to our story here? Right, so looking, we have a nice parabola like this. So throwing stones. So Ricardo throws a stone off a bridge into a river below. The stone's height, h of x, is in meters above the water, x seconds after Ricardo threw it. Right, so we know we have a height in meters, and we know we have time in seconds. Right, so we have Ricardo throws a stone off a bridge. So let's say here's a bridge, wherever the starting point is, right? That's a y-intercept. You have Ricardo there. He's going to step into it and fling a stone off of this bridge, right? So it's going from here, it says here, to here, and it goes up, and it eventually hits the ground. Right, so our graph, we can draw this. So he throws a stone, goes up, hits the highest point, and it goes down, and like that, like a nice parabola. And the other side is just like that, dashed. Because it's there just for purposes of our parabola, but we know that time cannot go negative. So in this word problem, this side does not exist, so that's why we do dashed lines, but this is just continue on. Right? So we can tell that the height, initial height he threw it from was 32 meters. It reached a maximum height of 36 meters at 2 seconds, and it eventually hit the ground after 8 seconds. And that's how we can apply our parabola, throwing an object off of the bridge. There, so that's one example. Okay, another one. Okay, mobile app profit. So a certain company's main source of income is a mobile app. The company's annual profit, P of X. So we have a profit, P of X, in millions of dollars, and the app price, there is your x-axis. So we get our x-axis and our y-axis, which is the P of X. in millions of dollars. And it's modeled by this equation. So we're still going to find the x-intercepts. Right, set them both to 0, we get 3 and 11. So 3 and 11 are the x-intercepts. So let's say this is 3, this is 11. Right, just to make a little chart. Then we have find the midpoint. Add these two together, cut it in half. We get 7, and that's our midpoint. Right, stuck in the middle is 7. We substitute 7, we get 64. That's our height. Right, 7 comma 64. There. And our y-intercept, substitute 0 into our function, and we get negative 132. So it's going to run out of graphs. Let's say it was way down there. Negative $132 million. All right, so we have our parabola. It's not going to be perfect, just because it should make that hit that. Okay, that's our parabola, and we can see that we have the price, right? Price of $3 or $11, and we can tell our profit is going to be maximized at this point. So it's asking, what would be the company's profit if the app price is $0? So $0 is here. That'll be our y-intercept, and they would lose $132 million. Right? If you sell it for 0. So if you make all this product, you sell it, you give it away, you're going to lose all that money that you cost to produce it. So they lost $132 million. What's the company's maximum profit? Will be here, right? The highest profit. So if they priced it at $7, they would make the maximum profit $64 million. And we can see that they'll make 0 money if they priced it at $3, they would break even. If they price it at $11, they would break even. So a nice sweet spot where more people would buy it and still keep your demand without having too high of a price so nobody would buy it is $7. So we can use these parabolas to also do profits. So you can see how much money we're going to make, how much money we're going to lose, and predict those using parabolas, right? Quadratics. Okay, let's go to our first problem. So number 1. So a hovercraft takes off from a platform. Its height is h of x. So we have height, h of x here in meters. Our time is in seconds. There, that's our x-axis after takeoff. Right, so let's say our hovercraft is at a platform here. So hovercraft, we don't know, it's an amphibious vehicle, goes on land and water. So it's going to launch from that height, and it's going to follow a parabola and then hit the ground right there. And on this side, just to complete the parabola. There. Right, so it launches off this height, it's going to hit a maximum height, and then after so much time, it'll hit the water. There's our water, and there's just our placeholder. Okay, so we're going to find the x-intercepts first, our pointed points. So x-intercepts, we set each factor equal to 0. So x minus 11 equal to 0, x plus 3 equal to 0. Solve each one separately. X equals 11, x equals negative 3. So we have our x-intercepts, 11, 0, and negative 3, 0. So 11, 0, negative 3, 0. And then we're going to apply that to the graph, right? So here's 11, 0. Here's negative 3, 0. There. Right, so we know It's going to go over time. It's going to hit our x-axis or the water at 11 seconds. And this is just our placeholder, the negative time. So we want to find the vertex, where the vertex is always stuck in the middle of our two x-intercepts, right in the middle. So to find the middle, so vertex x value is first. So first we need to find right the middle, the midpoint. So we add up both of our x-intercepts, 11 plus negative 3, and then we find the middle, we cut it in half. Right? Add it together, cut it in half. So 11 minus 3 is 8, divided by 2 is 4. So our vertex is at 4, comma, we don't know yet. So we're going to find the y value. And we're going to substitute the 4 into our function. So it's h of x. So h of 4 is equal to negative parentheses 4 minus 11 times 4 plus 3. Using our original function, right? 4 minus 11, 4 plus 3, with the negative in front. We still have that negative in front. So we have negative 4 minus 11 is negative 7. 4 plus 3 is positive 7. And that's equal to negative times a negative is positive. 7 times 7, 49. So our vertex is at 4, comma, 49. So 449. There. So we can see our vertex is going to be right in the middle, which is at 4 seconds. And the height is going to go all the way up to 49. So at 4 seconds, it has a height of 49 meters. And that will be our highest or maximum height there. So it takes off. Maximum height after 4 seconds is 49 meters. And it hits 0 height at 11 seconds. And to find the original height, we have to find the y-intercept. Right, so y-intercept, and then we can tell, right, this is a maximum of 49. So it's going to be max 49. And our y-intercept is going to be 0 something. So y-intercept, to substitute 0. So h of 0, so height at 0 seconds. So negative 0 minus 11 times 0 plus 3. So 0 minus 11, negative 11. 0 plus 3, 3. So you have the negative in the front. Negative 11 times 3, negative 33. Negative times a negative is a positive, so this is just positive 33. So our y-intercept is at 0, comma 33. Yeah. And that's our y-intercept. So we know our hovercraft took off at 0 seconds and a height of 33 meters. That's how we work our parabola. All right, so important part, x-intercepts given by the zeros of our factors. So negative 3 and 11. Vertex stuck in the middle, which is added together, divide by 2, 4. Substitute the 4 to find the height. We got 49. And then the original height, we substitute 0 at 0 seconds. We got 33 meters. Here. So we can tell our important point. So it took off at 33 meters. After 4 seconds, it had a maximum height of 49 meters. and it landed after 11 seconds. So part C says, what is the height of the hovercraft at time of takeoff? We know it's 33 meters. Next part, what will the hovercraft's maximum height be after takeoff and after how many seconds? So we can see our graph. Maximum height is there, 4 seconds, 49 meters. All right, so maximum height is 49 meters at 4 seconds. Last question. How many seconds after takeoff will the hovercraft land on the ground? So we can see it's going to land at 11 seconds. There. And that's how we get that. So that's the applications of using parabolas and factored form to find our important points, x-intercepts, vertex, and our y-intercept, which is always our starting point because that's like 0 time. All right.